Imagine, for a moment, a single particle of light. We call it a photon. Right now, as you lie there, a photon just like it might be rested gently on your eyelid, or perhaps it is bouncing off a window pane nearby. It feels instantaneous, as if the light simply appears the moment a switch is flipped or the sun rises. But the truth is much deeper and far more patient. The light that warms your skin today began its journey an incredibly long time ago. It is a traveler that is older than every city on earth, older than the oldest written words, and perhaps even older than the very idea of humanity itself. This little spark of energy has been trying to reach you for tens of thousands of years, navigating a labyrinth of impossible density before it ever tasted the freedom of open space. Before we follow this tiny traveler on its epic journey from the heart of our star to the quiet of your room, I invite you to settle in. Make sure you are as comfortable as you can be. If there is a stray thought from the day, let it drift away like a cloud on a still afternoon. If you find these nighttime journeys helpful and wish to join us for more, you are always welcome to subscribe and become a part of our quiet community. It is a gentle way to support the channel while ensuring you always have a peaceful place to return to when the world feels a bit too loud. But for now, there is nothing you need to do and nowhere else you need to be. Let's take a slow, deep breath together. Breathe in through your nose, feeling the cool air fill your lungs, and exhale slowly, letting your muscles soften into the mattress. With every breath, the world around you becomes a little more distant, a little more blurred. We are leaving the familiar behind. We are traveling far beyond the roof above you, past the silent trees and the sleeping streets, moving upward through the blue haze of the atmosphere and into the velvet blackness of the solar system. We are heading toward the great center. We are moving toward the sun. As we approach, the scale of what we see begins to defy imagination. It is not just a glowing ball in the sky. It is a vast, roiling ocean of fire and gravity that holds our entire world in its steady golden grip. We are going deeper still, past the glowing surface, past the swirling currents of plasma, down into the very core of the star. This is the starting point of our story. Here, in the absolute center of our solar system, in a place of unimaginable pressure and ancient power, our journey begins. This is the cradle of light, the place where a single photon is about to be born. To truly understand the journey of our tiny spark of light, we must first try to grasp the sheer silent magnitude of the place where it begins. As we descend through the outer layers of the sun, the scale of this celestial giant becomes almost impossible to hold in the mind. If you were to imagine the sun as a vast hollow sphere, a vessel of golden light, you could pour 1,300,000 Earths inside it before it was full. Our entire world, with its deep oceans, its towering mountain ranges, and its billions of people, would be nothing more than a small marble lost in the vastness of this solar sea. It is a scale of existence that is both humbling and strangely comforting, a reminder of how much larger the universe is than our daily worries. This immense size brings with it a force that defines everything within the sun. Gravity. It is an invisible, persistent pull, a weight that never tires. Every atom of gas, every swirling cloud of plasma is being drawn inward toward the center. This is not the sharp, sudden pull of a fall, but a heavy, constant pressing down. Imagine the weight of an entire star, octillions of tons of matter, all leaning inward, seeking the very heart of the sphere. This pressure is so great that it creates an environment unlike anything we can experience on our cool, solid Earth. We have now reached that heart. We are standing or floating in the solar core. This is a region that extends from the very center out to about a quarter of the way to the surface. Though it is the source of all the sun's incredible power, there is a surprising quality to the core, a sense of profound, heavy stillness. It isn't the stillness of an empty room, but the stillness of a place so densely packed that movement itself becomes a slow, deliberate process. The pressure here is staggering, more than 260 billion times the atmospheric pressure we feel at sea level. In this deep, dark sanctuary, the matter is squeezed so tightly that it is 15 times denser than lead. Yet it remains a fluid, a state of being that defies our common understanding of solid or liquid. Here, in the absolute center, the weight of the entire star creates a crucible of potential. It is a place of waiting. Every particle is pressed against its neighbor, held in a tight rhythmic embrace by the gravity of the layers above. There is no wind here, no sound, only the immense, silent thrum of atoms being pushed together by the sheer scale of the universe. It is in this dense, quiet pressure cooker that the conditions are finally right for something miraculous to happen. The environment is prepared, the stage is set, and the ancient dance of the stars is about to begin. Within this heavy, silent pressure of the sun's core, a second force begins to manifest, one that is perhaps even harder to fathom than the weight of the star itself. It is the heat. In our world, we understand heat through the warmth of a sunbeam on our skin, or the steam rising from a bowl of soup. But here, at the heart of the solar system, the temperature reaches a staggering 15 million degrees Celsius. This is a number so vast that it transcends our physical senses, moving into the realm of pure mathematical energy. It is not a flickering flame or a scorching desert wind. It is a fundamental vibration of the universe, a state of being where every particle is infused with an incredible, invisible power. At these temperatures, matter can no longer exist in the forms we know on Earth. We are familiar with solids that hold their shape, liquids that flow, and gases that drift through the air. But in the core of the sun, the intense heat creates a fourth state of matter, plasma. Imagine a world where atoms are no longer whole. Usually, an atom is a tidy structure with electrons orbiting a central nucleus like tiny moons around a planet. But here, the energy is so great that those electrons are stripped away, torn loose by the sheer speed of their own motion. They become a sea of wandering sparks roaming freely through the core, no longer bound to any single home. This creates what scientists often call a solar soup, a thick, glowing, and electrically charged fluid that fills every corner of the solar interior. It is a medium that is both incredibly dense and strangely fluid, a place where the rules of the surface world no longer apply. If you could look through this soup, you wouldn't see a clear void, but a shimmering, translucent fog of light and motion. It is a landscape of pure energy, where the very fabric of matter is being stirred by the heat of the star's birth. Within this luminous soup, the primary actors are the nuclei of hydrogen, the simplest and most abundant element in the cosmos. These are essentially single protons, tiny points of positive charge. On a cool planet like ours, these protons would push away from one another, repelled by their shared electrical charge, like two magnets of the same pole being forced together. But here, in the 15 million degree heart of the sun, they are moving with such frantic, high-speed energy that they can no longer keep their distance. They engage in an ancient rhythmic dance, zigzagging through the plasma at impossible speeds. They collide and carom off one another in a constant, invisible ballet. The density is so high, remember, 15 times denser than lead, that these particles are never truly alone. They are always within reach of a neighbor, always part of the collective pulse of the core. The atmosphere is one of intense, vibrant activity, yet because it is so tightly packed, it feels like a slow-motion swirl, a heavy and deliberate movement that has been continuing for billions of years. This is the environment of the deep sun, a place of extreme pressure, unimaginable heat, and a crowded, energetic soup of particles, all waiting for the one moment where their paths will finally perfectly align. It is a state of perpetual readiness, a cosmic stage where the smallest particles in existence are about to perform the greatest transformation in the universe. This transformation is known as nuclear fusion, the silent engine that powers every star in the night sky. In the extreme crush of the core, the hydrogen nuclei are pressed so closely together that they can no longer resist one another's presence. They overcome the invisible barrier of their own electrical charge, and for a fleeting moment, they touch. This is not a collision of violence, but a profound embrace. 4 hydrogen nuclei merge, shedding their individual identities to become something new, a single nucleus of helium. It is the alchemy of the cosmos, a building block of the universe being forged in the dark, heavy center of our sun. But there is a beautiful secret hidden within this process. If you were to weigh the 4 hydrogen nuclei before they fused, and then weigh the single helium nucleus afterward, you would find that a tiny fraction of the original mass has simply vanished. It is less than 1% of the total, a sliver of matter so small it seems insignificant. Yet, in the universe, nothing is ever truly lost. This missing mass has been transformed, obeying the elegant law of mass-energy equivalence, the realization that energy and matter are two sides of the same coin, governed by the speed of light. As the particles fuse, that tiny bit of matter is released as a burst of pure radiant energy. This is the moment of birth. Out of the heavy stillness of the core, a tiny pulse of light is exhaled. This is our photon. It is a single unit of energy, a messenger from the heart of the star, carrying the signature of the sun's power. At this stage, our photon is not the gentle, golden light we see dancing on the leaves of a tree or warming our skin on a summer afternoon. It is born as a gamma ray, the most energetic form of light in the electromagnetic spectrum. It vibrates with an intensity that is invisible to the human eye, a high-frequency whisper of power that would be far too strong for our world to handle directly. It is a strange thought to consider that the light which will one day help a flower grow or guide a traveler home begins its life as something so different, so fierce and and unseen. But for now, our photon exists only as this invisible spark, a high-energy gamma ray officially entering the long, crowded history of the sun's interior. It has been created in a flash of fusion, a tiny part of the 4 million tons of matter the sun converts into energy every single second. Our photon is now a traveler, ready to begin its long journey from the center of the sun toward the edge of the world. It is small, it is silent, and it is filled with the ancient power of the stars. It stands at the very beginning of a path that will take it through layers of density we can hardly imagine, moving from the site of its creation into the vast dark unknown of the solar interior. Our photon is now a tiny invisible spark of immense potential. It carries with it the raw, unbridled energy of the nuclear furnace, vibrating with a frequency so high it exists far beyond the colors of the rainbow. As a gamma ray, it is the most powerful form of light, a concentrated packet of energy that, in the open emptiness of space, could travel across the entire galaxy without ever slowing down. But here, in the very heart of the sun, the journey is not one of speed, but of incredible patience. The environment where our photon has been born is unlike anything we experience on Earth. It is a place of staggering density. To help your mind settle into the scale of this, imagine a glass of cool, clear water. Now, imagine that same volume of space packed so tightly with matter that it becomes 150 times heavier than that water. It is a density greater than solid lead, yet because of the extreme heat, it remains a fluid plasma, a thick, heavy soup of particles crushed together by the weight of the entire sun pressing inward. In this crowded, pressurized world, there is no room for a straight line. Our photon, despite its nature to move at the staggering speed of light, finds itself in a labyrinth with no clear exit. It attempts to move outward, to fly away from the core and toward the distant stars, but it cannot go far. It travels only a fraction of a millimeter, a distance smaller than the thickness of a single strand of silk. Before it encounters its first obstacle, it strikes a free-roaming electron or a stray nucleus in the dense plasma. In that tiny, silent collision, the photon is absorbed and then almost immediately released again, cast off in a new, unpredictable direction. It might move slightly to the left, or perhaps it is knocked backward, deeper into the port from which it just emerged. This is the beginning of what scientists call the random walk. It is a slow, rhythmic dance of zigzags and detours. Imagine a person trying to walk through a vast, joyful, but incredibly crowded room where everyone is shoulder to shoulder. You might take one step forward, only to be gently bumped 2 steps to the side, or find yourself turned around entirely. There is no path, only the constant repetitive motion of contact and release. For our photon, this process will happen trillions upon trillions of times. It is not a journey of miles, but a journey of encounters. Each time it hits a particle, it loses a tiny, imperceptible bit of its initial ferocity, settling into the long, slow rhythm of the sun's interior. There is no rush here. The sun has been shining for billions of years, and it will continue to shine for billions more. Our photon is part of a grand, leisurely tradition a slow migration of energy that has been happening since the dawn of our solar system. As you breathe slowly and feel the weight of your own rest, try to visualize this tiny spark moving through the heavy golden dark of the core. It is not lost. It is simply part of the process. It is beginning a trek that will span more time than all of human history. A patient movement through the densest part of the star. The core is behind it. Yet it is still all around it, a thick blanket of matter that keeps the photon safe and contained as it begins its first few steps toward the surface. The journey is long, but it has all the time in the world. This path, this erratic and wandering trail, is what astronomers call the random walk. It is the reason why the light hitting your face today is actually ancient, an antique energy that has spent an eternity trying to find its way out of the dark. To understand why it takes so long, we must look at the sheer crowdedness of the sun's interior. Even though the photon travels at the ultimate speed, it cannot maintain a straight line for more than a fraction of a second. Imagine a silver pinball, but instead of moving with a metallic clatter, it moves with a soft, silent grace. This pinball is launched into a machine that is millions of miles wide, filled with billions upon billions of bumpers. Every time our photon travels a tiny distance, perhaps only the width of a human hair, it strikes an electron. These electrons are everywhere, buzzing in the plasma like a thick golden mist. When the photon hits an electron, it doesn't break or stop. Instead, it scatters. It is deflected. It might be nudged a few degrees to the right, or it might be sent flying directly back toward the very center of the sun where it began. There is no compass here, no north or south, no up or down. To the photon, every direction is the same. It is a wanderer in a desert of light, taking one step forward and 2 steps back, then 3 steps to the side and 1 step diagonally. It is a journey of pure chance, a sequence of trillions of tiny accidents that eventually, very slowly, drift away from the center. Because of this constant bouncing, the photon's actual path is incredibly long. If it could fly in a straight line from the core, it would reach the surface of the sun in just over 2 seconds. But because of the random walk, it ends up traveling a distance many times the circumference of the entire solar system, all while trapped inside the body of a single star. It is a paradox of motion, moving at the fastest speed possible, yet making almost no progress at all. This is why the journey through the sun's interior is measured not in hours or days, but in millennia. While empires rise and fall on Earth, while forests grow and oceans shift, this single bit of energy is still just trying to move a few more miles toward the surface. It is a lesson in ultimate patience. There is no friction to slow it down, only the endless, repetitive cycle of contact and redirection. As you lie there, perhaps feeling the stillness of your own room, you can imagine the quiet persistence of this light. It does not get frustrated. It does not tire. It simply continues its dance, bouncing from one particle to the next, slowly, inevitably, working its way through this dense, heavy fog of the interior. Each bounce is a soft pulse in the heart of the star, a tiny beat in a rhythm that lasts for tens of thousands of years. The photon is in no hurry, and for now, neither are we. We are simply drifting with it, watching the zigzags, feeling the slow, steady pull of the journey outward, moving through a space where time seems to stretch and expand into a comfortable, infinite quiet. To truly understand the journey of this single light particle, we must look at the clock of the cosmos, a clock that moves much more slowly than the ones we keep on our bedside tables. Scientists estimate that it can take anywhere from 10,000 to 100,000 years for a photon to work its way from the core to the surface. Imagine that for a moment. If the photon reaching Earth today began its journey 100,000 years ago, it was born at a time when vast ice sheets covered much of the northern hemisphere. It was born while our ancestors were first beginning to tell stories around flickering fires long before the first cities were built, long before the first words were written down. While civilizations rose and fell, while forests grew into coal and mountains were worn smooth by the wind, this little spark of energy was simply continuing its quiet, zigzagging path through the sun's interior. It has been traveling since the dawn of human history, moving through the dark, dense plasma with a persistence that is almost impossible to imagine. Yet, in the strange reality of physics, the photon feels none of this. Because it travels at the speed of light, time as we understand it does not exist for the photon. It does not age. It does not grow weary. It exists in a state of eternal now, a single continuous moment of being. It is as fresh and vibrant today as it was the millisecond it was forged in the nuclear furnace of the core. As you listen to the sound of my voice, let that sense of vast, unhurried time settle over you like a warm blanket. There is no rush. There is no deadline. Just as the photon has all the time in the universe to complete its journey, you have all the time you need to find your rest. Take a slow, deep breath in, feeling the air fill your lungs, and then let it out even more slowly. Imagine the stillness of that photon, moving through the deep golden silence of the sun. It is not struggling. It is simply participating in the natural order of the star. We are now deep within the radiative zone, the thickest and most expansive part of the sun's interior. It is a place of incredible density, where the matter is so tightly packed that even light, the fastest thing in existence, is slowed to a crawl. In this region, the sun is a vast glowing ocean of plasma, so thick that it would feel as heavy as lead, yet it remains a fluid, shifting environment. The photon is a tiny, bright wanderer in this heavy fog, moving through a space that is silent, warm, and utterly constant. Deepening our sense of this place, we can visualize the radiative zone as a realm of pure, filtered light. There are no shadows here, only a pervasive, all-encompassing glow. The photon isn't just moving through the sun, it is being cradled by it. Every collision with an electron, every change in direction, is part of a grand celestial architecture. The journey is long, yes, but it is also certain. The light is moving toward the surface at its own pace, governed by the laws of the universe, moving through the ancient, quiet layers with a grace that only comes from having 100,000 years to spare. We are drifting with it now, leaving the core far behind, entering the vast, peaceful middle ground of the star, where the only thing that matters is the next gentle bounce. The radiative zone is the sun's most massive interior layer, a thick, silent expanse that stretches for hundreds of thousands of miles. Here, the density is so immense that space itself seems to be made of liquid light. In this environment, our photon cannot simply fly outward. It is trapped in a beautiful, frustratingly slow game of cosmic pinball. Every time it travels even a tiny distance, perhaps the width of a human hair, it strikes a particle. It is absorbed, held for a billionth of a second, and then released again in a completely random direction. It might go left, it might go right, or it might even be sent back toward the core where it began. This is why the journey is so incredibly long. The light is not traveling a straight line to the surface. It is tracing a path so complex and winding that it would take a computer an eternity to map it. As the photon weaves through this dense forest of atoms, something remarkable happens. It begins to change its very nature. When it was first born in the core, it was a gamma ray, the most energetic, high-frequency form of light in the universe. But as it bounces off one particle after another, it loses a tiny, microscopic amount of its original energy. It is as if the photon is shedding its heavy coat, piece by piece, as it moves further from the furnace. This process is called thermalization. Slowly, almost imperceptibly, the high-energy gamma ray is mellowing. It is shifting down the spectrum, transforming into an X-ray. If you could see this change, you might imagine the photon's wavelength, the distance between its peaks, stretching out. In the core, it was a tight, rapid vibration like a high-pitched note on a violin. As it moves through the radiative zone, that vibration is slowing down, becoming a slightly lower, calmer frequency. The waves are getting longer, softer, and less intense. It is a graceful stretching, a relaxation of the light's energy as it navigates the vast, heavy silence of the sun's interior. This shift is not a loss, but a transition. It is the way the sun prepares its energy to eventually meet the cold of space. The photon is becoming less of a sharp spark and more of a steady, warming glow. And yet, even with this change, the journey remains slow. We are moving through the largest part of the star, a region that holds the vast majority of the sun's mass. Every inch gained toward the surface is a victory of persistence. The photon continues its unhurried dance, drifting through the golden fog, moving outward with a patience that matches the turning of the stars. We are well into the thickest part of the journey now, surrounded by the quiet, heavy pressure of the radiative zone, watching as the light subtly shifts its color and its soul, preparing for the layers yet to come. There is no wind here, no sound, only the endless, gentle scattering of light against matter, a process that has been happening for billions of years and will continue for billions more. In this layer, time and space seem to merge into a single, glowing experience of movement. In this vast, glowing interior, there is a profound sense of order. Even though our photon is bouncing and turning in what seems like a chaotic maze, it is actually part of a grand celestial architecture that keeps the entire sun held together. This is the state of thermal equilibrium, a perfect, silent tug of war that has been going on for billions of years. On one side, The immense weight of the sun's outer layers is constantly pressing down, trying to collapse the star under its own gravity. On the other side, the energy of billions upon billions of photons, including the one we are following, is pushing outward. This outward pressure from the light acts like a dirty, invisible pillar holding up the weight of the star and preventing it from falling in on itself. It is a beautiful, steady balance. If the sun were to push too hard, it would expand and cool. If gravity pulled too hard, the core would shrink and heat up. But instead, the sun finds a middle ground, a place of quiet persistence. Because of this balance, the sun remains a constant, reliable source of life. It is currently in its middle age, a long and peaceful period of its life that will last for billions more years. There is something deeply reassuring about this stability. In a universe that is often changing, the sun is a master of staying still, a massive anchor of light in the dark sea of space. It does not flicker or fade. It simply exists in a state of perfect, glowing composure. As we drift along with our photon, you might try to imagine what this environment feels like. It is not a place of wind or rushing air. It is a muffled, heavy world. The density here is so high that everything feels cushioned, as if you were moving through a sea of warm, liquid gold. There is no sound here, as we understand it. No echoes, no sharp noises. If there is a sound at all, it is a deep, low-frequency hum, a vibration so slow and resonant that it is felt rather than heard. It is the heartbeat of the star, a rhythmic pulse that signifies the constant, steady work of fusion happening deep below. This vibration is the only thing that breaks the total heavy silence of the interior. This environment is thick and slow, like a dream where every movement is deliberate and soft. The photon isn't rushing. It is being carried by the very structure of the star itself. There is no urgency here in the deep layers. The light is held in a state of grace, moving through a medium that is both incredibly dense and perfectly transparent to the slow passage of time. We are surrounded by a soft, pervasive glow that has no single source, a light that seems to come from everywhere at once. It is a place of total immersion, a golden sanctuary where the laws of physics create a harmony that allows the star to shine without flickering. In this heavy silence, the photon continues its long, patient, outward journey. It is supported by the very pressure it helps to create, a part of the star's living breath. Everything is exactly as it should be, balanced, stable, and calm. We are moving through the heart of a giant, yet it feels as quiet as a library at midnight. The immense power of the sun is tucked away behind this veil of equilibrium, manifesting only as a gentle, persistent push toward the surface. As we linger in this peaceful interior, we can feel the weight of the universe being held at bay by the simple, quiet strength of light. It is a place of absolute safety, where the forces of nature are in perfect agreement, allowing our journey to continue at its own natural, unhurried pace. Take a moment now, as we continue this long and patient journey, to check in with your own body. If you feel any lingering tension in your shoulders, let them drop just a fraction of an inch, allowing them to rest heavily against the surface beneath you. Notice the muscles in your face, especially around your eyes and your jaw. If your teeth are pressed together, allow your jaw to soften. and create a small space of ease. Take a slow, quiet breath in, and as you let it out, imagine yourself sinking deeper into the soft, warm glow of the sun's interior, perfectly safe and perfectly still. Our photon has been traveling for a very long time now. In the scale of human history, it might have begun its life when the first great civilizations were just beginning to dream of the stars tens of thousands of years ago. And yet, after all that time and all those billions of tiny collisions, we have finally reached a significant milestone. We are now roughly halfway to the surface. Behind us lies the intense, crowded heart of the star, and ahead of us lies the vast expanse of the outer layers. The journey so far has been one of incredible density. But as we move further from the core, the environment is beginning to change in subtle, gentle ways. One of the most noticeable changes is the temperature. Deep in the core, the heat was an unimaginable 15 million degrees Celsius, a temperature so high that atoms themselves could not hold together. But as we drift through the midsections of the radiative zone, the fire is beginning to mellow. The temperature has been steadily dropping, and now it sits at what scientists might call a relatively cool 7 million degrees, eventually dipping toward 2 or 3 million as we progress. Of course, cool is a relative term in the heart of a star, but for our photon, this represents a softening of the energy that surrounds it. The frantic, high-energy dance of the core has slowed down into a more graceful, rhythmic movement. The plasma here is still incredibly hot and dense, but it is no longer quite as packed as it was. Imagine a crowded room where slowly people begin to step apart, creating just a little more space to breathe and move. Because the particles are slightly further apart, the photon's random walk becomes just a tiny bit more efficient. The distances between collisions are growing, if only by a fraction of a millimeter. This doesn't mean the journey is suddenly fast. It is still a process of immense patience. But there is a sense of expansion, of feeling that the heavy weight of the keel is beginning to lift. We are transitioning now, moving away from the deep, silent interior and toward the outer layers of the sun's massive body. The light around us is shifting, its energy stretching out as it cools. This part of the sun acts like a giant insulator, keeping the heat of the core trapped for millennia, allowing it to leak out only in the steadiest, most controlled way. It is this slow release of energy that makes life possible, ensuring that the sun doesn't spend all its fuel at once, but instead glows with a steady, reliable light that lasts for billions of years. As we glide through this halfway point, the silence remains, but the character of the light feels different. It is less piercing, more diffused. We are leaving the realm of pure radiation and moving toward a place where the physical movement of the sun's matter will soon take over the task of carrying us to the surface. For now, we simply drift in this middle ground, suspended in a sea of glowing plasma that is cooling, expanding, and preparing for the final stages of the long climb upward. Everything is calm, everything is balanced, and we are exactly where we need to be. As we continue our slow, patient climb, we approach a very special and narrow boundary. This is a place of transition, a thin layer that scientists call the tachocline. Think of it as a delicate veil, only a small fraction of the sun's total thickness. Yet it is one of the most important regions in the entire star. Up until now, everything we have passed through, the core and the vast radiative zone, has been spinning together, almost like a solid ball of light and heat. It is a steady rhythmic rotation where every part moves in perfect synchronization with the rest. But here at the tachocline, that unity begins to shift. Just above us, the outer layers of the sun do not move as a single piece. Instead, they spin at different speeds, faster at the equator and slower near the poles. This creates a gentle, massive shearing motion, a sliding of one layer against another. It is a slow and grand movement, like the shifting of deep ocean currents, but on a scale that defies imagination. In this thin transition zone, something remarkable happens. Because of this difference in speed, the sun's magnetic field is born. Imagine invisible threads of energy being stretched and twisted by the motion of the plasma. These magnetic lines are like long, glowing ribbons that wrap around the interior of the sun, gathering strength as they are pulled and braided by the star's rotation. You can almost feel the subtle tension in the space around our photon, a soft magnetic hum that guides the flow of energy. These invisible lines are not chaotic. They are part of the sun's great heartbeat, the dynamo that powers its activity. They are the scaffolding upon which the rest of the journey will be built. As our photon passes through this shimmering boundary, the environment starts to feel less like a dense, static sea and more like a living, moving landscape. The stillness of the interior is giving way to something more dynamic. We are now standing on the doorstep of a new realm. The way the energy moves is about to change completely. No longer will the light have to bounce and scatter on its own through the dense plasma. Instead, it is about to be carried upward by the very matter of the sun itself. We are leaving the radiative zone behind and preparing to enter the convective zone, a place where the sun begins to stir and breathe in a way we haven't seen before. Take a moment to settle into this transition, feeling the steady pull of the magnetic lines as we move toward the next chapter of this incredible journey. The pressure is easing, the path is opening, and the surface is slowly, surely drawing closer. As we cross the threshold of the tachocline, the very nature of the sun begins to change. We have entered the convective zone, a region that spans the outer third of the star's interior. If the radiative zone was a dense, heavy fog that light had to struggle through, the convective zone is a vast, churning ocean of plasma. Here, the rules of the journey shift. The energy no longer relies solely on the slow, jagged scattering of photons from one particle to another. Instead, the sun begins to move its own weight to carry the heat outward. Imagine, if you will, a large pot of thick, hearty soup simmering on a very low flame. As the liquid at the bottom warms up, it becomes lighter and more buoyant. It begins to rise in soft, rolling plumes toward the surface. When it reaches the top, it releases its heat, cools down, and gently sinks back to the bottom to begin the cycle again. This is exactly what is happening here, but on a scale that is truly gargantuan. The sun is effectively boiling, though with a slow and rhythmic grace that spans thousands of miles. Our photon is no longer just a wanderer in the dark. It is now being cradled within one of these massive plumes of hot plasma, a giant bubble of energy and matter. These plumes are like slow-motion elevators rising from the deep interior toward the distant surface. You can feel the change in the environment. The crushing pressure we felt in the core is starting to lift, and the density of the plasma is thinning out. There is a sense of lightness here, a feeling of being swept up in a great upward current. As we ride this rising plume, the movement feels incredibly steady and rhythmic. It is a pulse, a heartbeat of the star itself. We are moving faster now, carried by the physical motion of the gas. The random walk of the past 100,000 years has given way to a more purposeful direction. We are part of a giant conveyor belt of light. These bubbles of plasma are not small. They are vast structures of heat, stretching for thousands of kilometers, undulating with a slow, powerful energy. In this part of the sun, the magnetic lines we encountered earlier act like invisible guides, threading through the rising and falling currents. The plasma flows around and along these lines, creating a complex but beautiful dance of motion. It is a landscape of constant, gentle upheaval. For our photon, this is a moment of transition. The long, silent wait in the radiative zone is over, and the final stages of the journey to the surface have truly begun. Take a deep, slow breath and imagine yourself drifting upward on this warm, golden current. There is no effort required now. You are simply being carried, rising through the layers of the star, moving ever closer to the light of day. The pace is calm, the motion is fluid, and the destination is finally coming into view. We are rising through the convective zone, drifting on a sea of golden bubbles as the sun continues its eternal rhythmic breath. The environment is becoming less crowded, the energy is more focused, and the path ahead is clearer than it has been for millennia. We are no longer struggling against the density. We are flowing with it. Imagine, if you will, a large pot of thick, hearty soup simmering on a very low flame. As the liquid at the bottom warms, it becomes lighter and begins to rise in soft, rolling circles. At the surface, it releases its heat, cools, and then gently sinks back down to the bottom to begin the cycle again. This simple process of convection is exactly what is happening within the sun, but on a scale that defies the imagination. These massive bubbles of plasma are known as convection cells, and they are the great engines of the sun's outer layers. But unlike the small bubbles in a kitchen pot, the scale here is truly gargantuan. A single one of these rising plumes can be the size of an entire continent on Earth. Some are even larger than our entire planet, vast columns of superheated gas surging upward through the darkness. Our photon is nestled safely within one of these continental-sized bubbles, being carried toward the surface like a passenger on a slow, steady elevator. The heavy, crushing pressure of the core has long since faded, replaced by a feeling of lightness and fluid motion. The journey is moving much faster now. In the deep radiative zone, the density was so high that our photon could barely move a fraction of an inch without hitting something. But here, in the convective zone, the plasma is thinning out. The atoms are further apart, leaving more room for the light to travel. The random walk that lasted for 100,000 years has transformed into a purposeful upward surge. Because the plasma itself is physically moving toward the surface, the photon is being swept along by the current. It is no longer just drifting, it is being delivered. As we rise, the speed of our progress continues to increase. The density of the sun's material is dropping with every mile we climb, and the resistance is melting away. The rhythmic pulsing of the convection cells creates a sense of steady, calming momentum. It is a vast, golden mosaic of motion, with millions of these cells rising and falling in a slow, eternal dance. You can feel the anticipation in the environment. The deep, heavy interior is behind us, and for the first time in millennia, the finish line is within reach. We are nearing the visible edge of the star, the boundary where the sun's body ends and the emptiness of space begins. The environment around our photon is changing. The light is becoming more focused, and the intense, invisible energy of the core is beginning to soften. We are approaching the threshold, the thin layer of the atmosphere where the plasma finally becomes transparent. After a journey that has lasted longer than human civilization, the photon is only a short distance away from the open sky. The path is clear, the motion is smooth, and the light of day is waiting just ahead. Take a long, slow breath and feel the weightlessness of this upward drift. The hardest part of the journey is over. The surface is calling. As our photon continues its steady, rhythmic ascent within the rising plumes of plasma, a profound transformation begins to take place. For thousands of years, this tiny packet of energy has been vibrating with the intense, invisible power of X-rays, high-energy light that can pass through almost anything but remains hidden from the human eye. But now, as the pressure of the sun's interior eases and the density of the gas thins, the photon itself begins to stretch. Imagine a tightly coiled spring slowly beginning to unwind, or a high, sharp musical note descending into a softer, richer tone. This is the shifting of the spectrum. The photon is losing a bit of its frenetic energy, its wavelength lengthening as it interacts with the cooling environment. It is transitioning from the harshness of X-rays into the realm of ultraviolet light. It is still invisible to us, still carrying a potent hum of energy, but it is becoming gentler, preparing itself for the world it is about to enter. Around us, the environment is changing just as dramatically. The temperature, which once soared at 15 million degrees in the heart of the star, has been falling steadily during our long journey outward. We have now crossed a silent threshold where the plasma is cooling to under 1 million degrees Celsius. While this would be unimaginably hot on Earth, here, in the context of the sun's massive furnace, it feels like a soft reprieve. The violent, chaotic dance of the deep interior has settled into a more organized, fluid motion. The plasma is no longer a crushing, opaque wall. It is becoming more translucent, like a thick fog beginning to lift as the sun rises on a misty morning. In this thinning atmosphere, we begin to see the first hints of what we would recognize as sunshine. It isn't the piercing white-hot radiation of the core anymore. Instead, a soft, pervasive glow begins to saturate the space around the photon. It is a deep golden luminosity that seems to emanate from the very fabric of the gas. You can almost feel the light wanting to break free, to leap away from the atoms that have held it captive for so many eons. We are now approaching the very edge of the sun's massive body, a region known as the photosphere. In the vast scale of the star, this layer is incredibly thin, a delicate shell, only a few hundred miles deep. It is the final gatekeeper, the boundary where the sun's density drops so low that light can finally travel in a straight line. After 100,000 years of bouncing, scattering, and drifting, the photon is sensing the proximity of the void. The soup of the convection zone is becoming a fine golden mist. Take a slow, deep breath and imagine that golden light surrounding you, warm and steady. The journey through the dark, heavy layers of the star is nearly complete. The photon is no longer a prisoner of the interior. It is a traveler, standing on the shore of a vast dark ocean, looking out toward the planets. The glow is brightening, the temperature is settling, and the final veil of the sun is about to be pulled back. We are standing on the precipice of the visible world, ready to witness the moment this ancient energy finally becomes the light that warms our skin and colors our sky. The surface is just ahead, shimmering with the promise of freedom. The photon has finally reached the photosphere. This is a very special place, the sphere of light. After thousands of years of being trapped in the dark, dense interior, we have arrived at the thin, glowing shell that marks the sun's visible surface. In the grand scale of the star, this layer is remarkably delicate, perhaps only 300 miles deep. If the sun were the size of a large library globe, the photosphere would be no thicker than a single coat of paint. Yet, it is here that the magic of the sun's light is finally revealed to the universe. It is the boundary between the solid-seeming body of the star and the endless reaches of the cosmos. As we drift through this thinning mist of plasma, the view below us is breathtakingly beautiful. The surface isn't smooth. It is textured with what astronomers call granules. Imagine looking down at a vast infinite field of glowing golden grains, each one shifting and shimmering with a slow rhythmic pulse. These granules are actually the tops of those massive convection cells we traveled through earlier, the giant bubbles of hot gas rising from the deep. Each individual grain is roughly the size of a large country on Earth, perhaps the size of Texas or France. They appear bright in the center, where the hot gas is surging upward, and darker at the edges, where the cooler gas begins to sink back down into the depths. It is a slow-motion boiling, a gentle, golden honeycomb that stretches out in every direction as far as the eye can see. The motion is fluid and graceful, like the surface of a simmering pot of honey. The temperature here has undergone a final dramatic transformation. We are no longer surrounded by the millions of degrees of the interior. In the photosphere, the temperature has settled to a relatively cool 5,500 degrees Celsius. To our human senses, this is still incredibly hot, but in the life of a star, it is a peaceful, temperate zone. This specific temperature is what gives the sun its familiar yellow-white hue. It is the temperature of a perfect summer afternoon, condensed into the very fabric of the plasma. The energy that was once a violent, high-frequency gamma ray has been stretched and calmed, transformed into the gentle, visible light that the human eye is designed to see. Take a moment to settle into this warmth. Feel the way the light is changing. The crushing weight of the sun's gravity is still there, holding the star together, but the density of the matter around us is fading away. The soup is becoming a clear, radiant atmosphere. For the first time in 100,000 years, the photon can sense the openness of the space ahead. The collisions are becoming fewer and further between. The path is no longer a zigzagging maze. It is becoming a straight line toward the stars. We are standing on the very edge of the sun's crown, watching the golden grains dance beneath us, waiting for that one final moment when the last atom steps aside and lets us go. The long, slow journey through the heart of the star is nearly at its end, and the vast, cool silence of the solar system is waiting just a few miles away. The light is ready to fly. As we float here at the very edge of the photosphere, the environment undergoes a profound and silent change. The golden boiling soup of the sun's surface is thinning out, dissolving into a fine, translucent mist. For the first time in its incredibly long life, after 100,000 years of being trapped in the dark, dense interior, the photon can finally see the horizon. It isn't a horizon like the one we see on Earth, where the land meets the sky. Instead, it is the threshold where matter meets the void. The plasma here is now so sparse that it is becoming transparent. The fog that has scattered and absorbed our light for millennia is lifting, revealing the deep velvet blackness of the cosmos stretching out in every direction. It is a moment of immense clarity and stillness. Imagine the photon moving through these final, wispy layers of the sun's atmosphere. The density is so low now that the chance of hitting another particle is dropping with every passing second. But the journey isn't quite over. There is one final interaction waiting. In this thinning layer of hydrogen ions and free electrons, the photon encounters its very last obstacle. It is a single, solitary hydrogen nucleus drifting in the solar breeze. There is a final gentle collision, a last bounce that redirects the photon one more time. This is the final scattering event, the very last moment the photon will be touched or influenced by the matter of the star that gave it birth. With this one last nudge, the photon is aligned perfectly with the open road of the universe. And then it happens. The breakaway. In the blink of an eye, the photon passes the last physical barrier of the sun. There are no more particles to hit, no more electrons to dance with, and no more ions to block the way. The random walk that defined its existence for tens of thousands of years is suddenly, finally, over. The path ahead is perfectly clear. For the first time, the photon can travel in a perfectly straight line, unburdened and free. It finally achieves its true, uninhibited velocity, the speed of light. 300,000 kilometers every single second. The transition is startlingly peaceful. One moment, we were submerged in the frantic, glowing energy of the photosphere, surrounded by the heat and the golden granules of the sun's surface. The next moment, we have stepped off the edge of the world and into the infinite. The pressure of the sun's interior is gone, replaced by the weightless, silent vacuum of space. The intense, crowded heat of the star's body is left behind, and the cool, dark expanse of the solar system opens up to receive us. As we look back, the sun no longer feels like a place we are inside of. It is becoming a great lantern, a massive, glowing sphere that stays behind as we fall forward into the dark. We are no longer a part of the sun's body. We are now a messenger, a tiny packet of energy, carrying the story of the core out into the reaches of the stars. The long wait is over, and the dash across the void has begun. Take a slow, deep breath and feel the weightlessness of this new beginning. The journey is no longer a crawl, it is a flight. Now, we are moving at the ultimate speed of the universe. In the vacuum of space, there is nothing to slow us down, nothing to deflect our path, and nothing to dim our glow. We are traveling at approximately 300,000 kilometers per second, the cosmic speed limit. At this velocity, you could circle the entire Earth 7.5 times in a single second. It is a speed so profound that it defies our everyday intuition. Yet in the staggering vastness of the solar system, it feels like a graceful, steady glide. After the 100,000 years we spent struggling through the dense interior of the sun, this sudden freedom feels like a long-awaited exhale. As we move further from the sun's surface, a remarkable change occurs. For the first time in our long history, there is silence. The sun is a place of unimaginable noise. The roar of rising plasma, the crackle of magnetic fields, and the constant thrum of nuclear fusion. But space is a vacuum, and sound requires a medium, like air or water, to travel. Without those particles to carry the vibrations, the roar of the star vanishes instantly. We are now bathed in a silence so deep and so absolute that it feels like a soft weight lifting off our shoulders. The pressure that squeezed us in the core is gone. The heat that buffeted us in the convective zone has fallen away. There is only the dark, cool velvet of the void and the steady, unwavering direction of our flight. Take a moment to visualize the sun behind us. As we move away at light speed, the sun begins to transform. When we were at the surface, the star was our entire horizon, a wall of golden fire that stretched forever in every direction. But now, as the seconds tick by, the sun begins to resolve into a shape. It becomes a perfect glowing sphere hanging in the darkness. We are witnessing the inverse square law in action. This is a fundamental rule of the universe. As we move away from a source of light, the intensity of that light fades, not just linearly, but exponentially. If we double our distance from the sun, the light becomes 4 times dimmer. If we triple the distance, it becomes 9 times dimmer. This geometric spreading is why the sun doesn't scorch the distant planets, and why it can appear as a gentle, warm friend to the earth, rather than a destructive furnace. The light is spreading out, filling the sphere of the solar system, becoming thinner and softer with every kilometer we traverse. We have now begun the final leg of our journey, the 8-minute and 20-second dash to Earth. It is a poetic contrast. It took nearly 100 millennia for the energy of fusion to work its way out of the star's heavy heart. But it will take less than 9 minutes to cross the 93 million miles of empty space that lie between the sun and our home. In the scale of the universe, we are moving through a neighborhood that is both incredibly empty and beautifully structured. The light we carry is no longer a chaotic burst of gamma radiation. It is a steady, visible beam, a golden thread connecting the center of our solar system to the life waiting on a small blue planet. Feel the stillness of this transit. There is no wind here to buffet us, no obstacles to navigate, just the silent, high-speed journey through the dark as the sun grows smaller and the stars ahead grow clearer. We are falling forward through the night, guided by the simple, elegant laws of physics. As we glide further into the dark, we realize that the space between the worlds is not quite as empty as it first appeared. While we move through a vacuum, it is a vacuum filled with a soft, invisible influence. Traveling alongside us, though much slower than our light speed pace, is the solar wind. This is a constant, shimmering tuft of charged particles, mostly protons and electrons, that the sun is continuously casting off into the void. If the light we carry is the sun's heartbeat, then the solar wind is its breath. It is a gentle but powerful exhale that fills the entire solar system, creating a vast bubble called the heliosphere. This bubble acts as a shield, pushing back against the cold pressure of the deep galaxy beyond. Even here, millions of miles away from the surface, we are still within the sun's protective embrace. We are drifting through a thin ethereal atmosphere that belongs to our star, a medium so sparse that an astronaut could never feel it, yet so vast that it defines the boundaries of our home in the cosmos. Imagine these particles as tiny, ghostly companions on our journey. While we will reach the Earth in minutes, these particles of the solar wind will take several days to make the same trip. We are passing them by, weaving through this stream of plasma like a bird flying through a high-altitude mist. There is a profound sense of continuity here. The sun does not simply end at its visible edge. It reaches out, touching every corner of the system with its magnetic fields and its rushing wind. It is a reminder that in the universe, nothing is truly isolated. Everything is connected by these invisible threads of energy and matter. The silence of space is not a hollow silence. It is a quiet, busy highway where light and matter dance together in the dark. Take a slow, deep breath now. As you inhale, imagine your lungs expanding just as the sun's influence expands outward into the night. And as you exhale, feel the tension leaving your body, mirroring the way the solar wind carries the heat of the star away into the cooling distance. There is no resistance here, no friction to slow us down. We are moving through the inner solar system, a region of space that is home to the 4 rocky planets, the small and sturdy worlds that sit closest to the fire. The scale of this place is difficult for the human mind to grasp, but for us, as a single photon, it feels like a grand open hallway. The darkness is not a wall, it is an invitation. Ahead of us, the first major milestone of our journey begins to reveal itself. It is a small, shadowed shape, a tiny pebble, caught in the glare of the sun. We are approaching the first world of the inner system, a place of extremes where the silence of the vacuum meets the harsh reality of the star's proximity. The path is clear, the light is steady, and the journey continues through the velvet dark. We are moving deeper into the neighborhood of the sun, heading toward the small cratered world that stands as the first sentinel of the solar system. We are passing the small cratered world now, a silent sentinel that has stood guard near the sun for billions of years. Mercury is a place of stark, quiet beauty, its surface etched with the history of the solar system. From our perspective as a beam of light, it looks very much like our own moon, a gray, dusty sphere covered in the scars of ancient impacts. There are vast plains of solidified lava and deep shadowed craters where the sun's rays never reach. It is a world that has been baked by the sun's intense radiation since its birth, yet it remains remarkably still, a testament to the endurance of rock in the face of the stars. As we glide past, we notice something fundamental about this little world. It is incredibly thin. Mercury possesses almost no atmosphere to speak of, only a tenuous layer of atoms captured from the solar wind or kicked up from the surface by micrometeorites. Because it lacks a protective blanket of air, Mercury cannot hold on to the energy it receives. During the long, slow day, the surface temperature rises to levels that would soften even the hardest metals. But as soon as the sun sets, that heat flees back into the vacuum of space. The nights are unimaginably cold, dropping hundreds of degrees below zero in a matter of hours. There is no wind to carry the warmth from one side to the other, no clouds to trap the heat, and no rain to soften the jagged edges of its craters. It is a world of absolute extremes, existing in a state of perpetual silent transition between the fire and the frost. There is a certain loneliness here, at the edge of the sun's primary influence. Although Mercury is our closest planetary neighbor to the sun, the distances involved are still staggering. We have traveled millions of miles to reach this point, and we will travel millions more before we see another sign of solid ground. In the vastness of the solar system, even the planets are like tiny islands in a shoreless ocean of night. The space between them is not just empty. It is a profound, heavy silence that stretches out in every direction. As we leave Mercury behind, shrinking back into a small gray dot against the blackness, we are reminded of the scale of the universe. The milestones of our journey are few and far between, separated by the immense dark velvet of the void. Take a moment to feel that space within yourself. Imagine the quiet of the vacuum, where there is no sound, no pressure, and no rush. Like the photon, you are simply drifting, carried by the momentum of a journey that began long ago. We are marking this first milestone, the first stop on our long path toward the Earth. The sun is still behind us, a great glowing presence that provides our light, but the horizon ahead is wide and open. We are moving further into the inner solar system, leaving the scorched plains of Mercury for the deeper reaches of the dark. The journey is steady, the pace is calm, and the next destination is already beginning to beckon from the distance, a bright and shrouded jewel waiting in the silence. As we continue our silent drift through the velvet dark, another world begins to grow in the distance. It is not a gray, cratered rock like Mercury, but a brilliant, steady jewel. This is Venus, often called the morning star or the evening star, because it shines with a light so fierce and pure that it is often the first thing we see in the twilight or the last thing to fade at dawn. Even from this distance, its glow is soft and inviting, a beacon in the immense stillness of the inner solar system. As we draw closer, we see that Venus is draped in a thick, impenetrable veil of clouds. Unlike the wispy white clouds of Earth, these are a full buttery yellow, composed of droplets of sulfuric acid and carbon dioxide. They wrap the planet in a permanent opaque shroud, hiding its surface from our view and from the direct gaze of the sun. There are no oceans here to reflect the blue of the sky, no green forest to absorb the light. There is only this endless, swirling sea of clouds, moving in a slow, heavy dance around the world. It is a beautiful, if lonely, sight, a world hidden away behind a curtain of its own making. While Mercury is the closest planet to the sun, it is Venus that holds the title of the hottest world in our solar system. This is because of the way it handles the light that reaches it. When a photon manages to penetrate those thick, heavy clouds and reach the rocky surface, it finds itself caught in a cycle of heat. The dense atmosphere acts like a massive greenhouse or a heavy, weighted blanket. The energy comes in, but the heat cannot easily escape back into the vacuum of space. It is trapped, bouncing between the ground and the base of the clouds, building up over millions of years until the surface temperature is hot enough to melt lead. It is a world of incredible muffled stillness, where the air is as thick as water, pressing down with a weight that would feel like being deep under an earthly ocean. But for most of the light that reaches Venus, the journey does not end on the surface. This planet has a very high albedo, which is the scientific measure of how much light a surface reflects. Because its clouds are so bright and thick, Venus reflects about 70% of the sunlight that hits it back into the void. This is why it appears so incredibly luminous to us on Earth. It acts as a mirror in the dark, catching the sun's rays and casting them back out into the night. It is this reflected light that we see from our windows, a soft, unwavering glow that has guided travelers and dreamers for as long as humans have looked at the sky. To look at Venus is to see the sun's energy being shared, redirected, and softened by a world that cannot hold it all. We glide past this brilliant hidden world, feeling the gentle tug of its gravity as it subtly curves our path. We are moving further outward now, leaving the extreme heat and the crushing pressures of the innermost planets behind. The void around us feels a little less harsh, a little more welcoming. We are entering the region of space known as the Goldilocks zone, the habitable zone where the distance from the sun is just right. It is not too hot and not too cold. Here, the energy of the sun is balanced, providing enough warmth to sustain liquid water and the delicate, breathing chemistry of life. We are moving toward a place where the light is not just a visitor, but a vital part of a living system. The dark velvet of the cosmos stretches out before us, and in the distance, a tiny pale blue spark is beginning to emerge from the shadows, waiting for us to arrive. As we leave the brilliant cloud-wrapped sphere of Venus behind, take a slow, deep breath. Feel the stillness of the space around you. Imagine the cosmos not as a cold, empty void, but as a vast, soft fabric, a deep, dark velvet that stretches out in every direction, cradling the stars and the planets in its silent folds. There is no wind here, no sound, and no resistance. It is a place of perfect, undisturbed peace. Let your shoulders relax into that same stillness. Let the weight of your body sink into your bed, much like the planets nestle into the gentle curves of space-time. There is no need to hurry and no need to exert any effort. We are simply drifting, carried by the fundamental laws of the universe. In this quiet expanse, our photon continues its journey. In the vacuum of space, light travels in what we perceive as a perfectly straight line. It does not need to weave or dodge as it did inside the sun. There are no more atoms to collide with, no more dense plasma to fight through. It is finally free to move at its full, breathtaking speed. Kokiki. However, space itself is not perfectly flat. According to the laws of reality, mass, like that of the sun and the planets, creates subtle dips and curves in the fabric of the cosmos. Our photon follows these invisible contours, gliding along the natural geometry of the universe. It is a path of least resistance, a graceful slide through the dimensions of height, width, and depth. Even though it is moving at 300,000 kilometers every second, there is no sense of rushing. In the grand scale of the solar system, this movement feels as steady and calm as a deep rhythmic breath. It is worth pausing to consider how much time has passed. Since the moment our photon broke free from the surface of the sun, only about 4 minutes have ticked by on a cosmic clock. In that short window, it has already crossed tens of millions of kilometers, passing the scorched rocks of Mercury and the glowing veils of Venus. We are now almost exactly halfway through the space-bound portion of our journey. If you were to look back now, the sun would appear slightly smaller, though still the dominant golden heart of everything. If you were to look ahead, the destination is becoming clearer, a tiny point of light in the distance that is slowly growing more distinct. 4 minutes. It is a humble amount of time, the length of a short song, or the time it takes to settle into a comfortable position before sleep. Yet, in these 4 minutes, the light has carried the energy born in the sun's core across a distance we can hardly imagine. It is midway between the fire of its birth and the cool blue embrace of its destination. The journey is quiet, predictable, and certain. There is nothing to interrupt this path, nothing to jar the senses. Just the steady, unwavering progress through the dark toward the small, pale spark that is waiting in the distance. We are suspended in this middle moment, drifting through the halfway point of the light's long-awaited arrival. The emptiness here is not lonely. It is a vast open room filled with the potential for life that lies just ahead. The light is calm, the path is clear, and we are exactly where we need to be. As we continue to glide through this middle space, we encounter a concept that astronomers call the solar constant. It is a beautiful rhythmic idea, the notion that the sun provides a steady, unwavering flow of energy to our part of the solar system. Even though the sun is a roiling, chaotic ball of plasma, the light it sends toward us is remarkably consistent. It is like a deep cosmic heartbeat, pulsing with a reliability that has allowed life to flourish for billions of years. At this distance from the sun, every square meter of space is bathed in about 1,361 watts of power. It is a silent, invisible river of energy, and our photon is just one tiny precious drop within that flow. This constancy is a form of celestial comfort. It is the guarantee that the sun will rise, that the earth will be warmed, and that the cycles of nature will continue their slow, patient dance. By now, our photon has completed its long transformation. It is no longer the high-energy, invisible gamma ray that was born in the crushing pressure of the core. Through its thousands of years of bouncing and scattering, it has lost much of its original frantic intensity. It has stretched out, its wavelength lengthening into something much more gentle. It is now a particle of visible light. If you could see it, it would appear as a soft yellow-white glow, the exact color of a peaceful morning. This is the light that paints the world, the light that allows us to see the faces of those we love and the beauty of the natural world. It is no longer a force of destruction, but a messenger of clarity. It carries with it the warmth of its origin, but it has been tempered by time and distance into something kind and restorative. Around our photon, the environment is one of extreme contrast. The vacuum of space is impossibly cold, a silent void where temperatures hover just a few degrees above absolute zero. In this vast dark freezer, there is no air to hold the heat, no soil to soak up the sun, and yet our photon carries its energy through this cold with perfect ease. It does not lose its warmth to the void, it simply passes through it, a tiny golden lantern moving through an endless, dark hallway. The vacuum does not fight the light. It simply steps aside, allowing the photon to maintain its integrity and its purpose. There is a profound stillness here, a quiet so deep it feels like a physical presence. It is a space of rest, a buffer between the fire of the stars and the life of the planets. And then, as we look ahead, something begins to change. For a long time, the view forward was nothing but the velvet black of the deep cosmos, punctuated by the distant, unblinking eyes of far-off stars. But now a new light is emerging. It is a tiny, delicate speck, barely more than a pinprick against the darkness. At first it is difficult to distinguish from the stars behind it, but as we draw closer, its color becomes undeniable. It is a pale, shimmering blue. This is our destination. Small, fragile world suspended in the immense silence of the universe. From this distance, Earth looks like a stray marble lost in a dark room, yet it is the most significant thing in our journey. It is a pale blue dot, as the astronomer Carl Sagan famously described it, a lonely, beautiful outpost of life. Seeing it there, so small and yet so vibrant, brings a sense of profound peace. We are no longer just moving through the void. We are moving toward home. The blue is soft, a sapphire spark that promises water, air, and the gentle embrace of an atmosphere. Our photon, born in the heart of a star 100,000 years ago, is finally closing the gap, drawn toward this tiny blue beacon like a traveler returning to a familiar shore. As we draw closer to that shimmering blue marble, we begin to encounter the first of Earth's many invisible layers. Long before we reach the air or the clouds, we find ourselves entering a vast protective cocoon known as the magnetosphere. It is a silent, unseen shield that stretches far out into the darkness, wrapping the entire planet in a gentle embrace. This shield is born deep within the Earth itself, created by the slow, rhythmic churning of liquid iron in the planet's outer core. It is as if the Earth has its own quiet heartbeat, sending out lines of magnetic force that reach tens of thousands of miles into space, creating a sanctuary for all the life that dwells below. Within this magnetic bubble, we are protected from the more turbulent energies of the solar system. It is the Earth's first line of defense, a soft but firm barrier that defines the beginning of our home's true territory. Imagine a great ship moving steadily through a calm sea. As it moves, it pushes the water aside, creating a soft, curved wave at its prow. This is very much like what happens at the very edge of Earth's influence, a region scientists call the bow shock. Here, the solar wind, that stream of fast-moving charged particles we've traveled alongside, reaches the boundary of Earth's magnetic field. It is a place of transition, where the sun's outgoing breath meets the Earth's quiet defense. The solar wind is slowed down and deflected, guided harmlessly around the planet, like water flowing around a smooth stone in a stream. Our photon, however, is unaffected by these magnetic tugs. Because it carries no electric charge, it passes through the bow shock with effortless grace, a silent witness to the way the Earth looks after its own. It glides through the invisible turbulence, moving steadily toward the blue light ahead. There is a profound sense of safety in this realization. We often think of space as a harsh and unforgiving place, but here, at the threshold of our home, we find a complex system of natural protections already in place. The magnetosphere acts as a filter, a cosmic gatekeeper that ensures only the gentlest energies reach the surface. It is a reminder that the world we inhabit is not just a rock floating in a void, but a carefully shielded cradle shaped by the simple, elegant laws of physics to harbor and protect. As our photon guides deeper into this magnetic territory, the chaotic environment of the open solar system fades away, replaced by the organized, rhythmic influence of the Earth. You can feel the change in the atmosphere of our journey. It is becoming more focused, more intimate. We are now moving through the very outer reaches of Earth's influence, a space where the planet's gravity and its magnetic field hold sway over everything that passes. The blue light of the Earth is growing larger now, filling more and more of our vision. We can start to see the subtle textures of the planet's silhouette, the thin glowing limb where the dark of space meets the first hint of the atmosphere. The journey that began in the crushing pressure of a distant star 100,000 years ago is now entering its most peaceful phase. We are no longer travelers in the wilderness. We are approaching the threshold of the sky, moving softly toward the layers of air that wait to welcome us home. We are now crossing into the exosphere, the very fringe of our world. If you were to look around, you wouldn't see a sudden wall of clouds or a dramatic change in the dark sky. Instead, it is a gradual velvet transition. In this outermost layer, the air is so incredibly thin that a single atom of hydrogen might wander for hundreds of kilometers without ever bumping into another. It is a place of immense stillness, a silver halo that surrounds the Earth like a gentle thought. Our photon moves through this sparse mist with ease, its path straight and true, guided by the same momentum that has carried it across the vast 93 million miles of the void. There is a quiet beauty in this edge of the world, where the last traces of Earth's gravity hold on to the stray atoms of the cosmos. As we drift lower, the environment begins to shift subtly. We are entering the thermosphere. Though it is still hundreds of miles above the mountains and oceans, the atmosphere here is beginning to perform its vital, silent work. This layer is a guardian. It catches the harshest energies the sun sends our way, the X-rays and the most intense ultraviolet waves, and absorbs them, preventing them from reaching the world below. Because of this absorption, the thermosphere is technically very warm. Yet because the atoms are so few and far between, that heat is a quiet, ethereal thing. It is energy held in suspension, a warm breath at the edge of the world. Even though the temperature is high, a traveler here would feel only the cold of space, because there are too few molecules to transfer that heat to the skin. It is a realm of physics that feels like a dream. In the distance, near the curve of the Earth's poles, we see a soft, ethereal glow. These are the auroras, the curtains of light that shimmer in the high, thin air. While our photon passes through the thermosphere without a sound, other particles, the charged ones from the solar wind, are being funneled toward the poles by the Earth's magnetic field. When they strike the gases here, they release bursts of color, emerald greens, soft pinks, and deep violets. They ripple like silk in a breeze that doesn't exist, a silent testament to the interaction between the star we left and the planet we are approaching. It is a beautiful, calming sight, a reminder of the many ways light and energy can manifest. You can almost imagine the soft hum of the planet as it interacts with the sun's outgoing energy, creating a masterpiece of color in the dark. We are descending now, leaving the realm of the aurora and the high energy shields behind. The blackness of space is slowly giving way to a deep dark indigo. The air is becoming just a little more substantial, a little more present. We are moving toward the layers of the sky that feel more familiar, where the atmosphere begins to act not just as a shield, but as a blanket. The journey is becoming more intimate, the scale of the universe shrinking down to the scale of a single beautiful planet. We are passing through the threshold of the high sky, sinking softly toward the calm, steady layers that lie just ahead, where the air begins to find its true weight, and the protection of the world becomes even more profound. As we continue our descent, we leave the thin electric heights of the thermosphere and enter a realm of profound stillness, the stratosphere. This is a layer of the atmosphere that feels different, more structured, more deliberate. In the world below, the air is often chaotic, filled with the churning of clouds and the rush of winds. But here, in the stratosphere, the air sits in calm, steady layers. It is a place of incredible peace, where the atmosphere begins to thicken, just enough to feel like a soft, invisible embrace. There are no storms here, no turbulent currents to toss a traveler about. It is a quiet corridor, a bridge between the vastness of the cosmos and the living world we call home. Take a moment to imagine this silence high above the highest mountains, where the air is cold and clear and the light moves with an unhurried grace. Within this calm expanse, we encounter one of the Earth's most vital wonders, the ozone layer. It is not a solid wall, but a delicate concentration of molecules, 3 oxygen atoms bonded together, scattered through this high-altitude air. As our photon passes through, it witnesses a silent, heroic process. The ozone layer acts as the world's most ancient and effective shield. It reaches out to catch the harshest, most energetic ultraviolet rays from the sun, absorbing their intensity before they can reach the delicate life below. It is a filter of incredible precision, allowing the gentle, life-giving light to pass through while holding back the rays that would be too much for the world to bear. It is because of this thin, invisible veil that the oceans can teem with life and the forests can grow green and tall. Imagine the feeling of stepping from a harsh, bright desert into the cool, dappled shade of a great oak tree. That is what the ozone layer provides for every living thing on Earth. It is a sanctuary. As we drift through this layer, there is a deep sense of being protected, of being shielded by a system that is perfectly tuned to your well-being. The Earth is not just a rock spinning in space. It is an active guardian, meticulously preparing the light and the air for the creatures that breathe and grow upon its surface. You can feel the safety of this arrangement, a perfect balance that has existed for millions of years, ensuring that the world remains a place of soft warmth rather than harsh radiation. It is a comforting thought to know that even when we are unaware of it, the very air above us is working to keep us safe and sound. We are moving lower now, through the bottom of the stratosphere. The air is becoming denser, more substantial with every mile we descend. We are approaching the boundary where the air becomes thick enough to support the flight of birds and the breath of lungs. The deep indigo of the high sky is beginning to soften, transitioning into the first hints of the familiar colors we see when we look up from the ground on a clear afternoon. We are leaving the stillness of the high layers and entering the vibrant, active part of the atmosphere, the place where the air finally feels like home. The journey of 93 million miles is almost complete, and the welcoming arms of the lower atmosphere are waiting to receive us, turning the raw energy of the sun into the soft, breathable reality of a beautiful day. As we descend further, the air around us begins to change in a way that feels deeply familiar. It is no longer the thin, ghostly veil of the high atmosphere. It is becoming thick, rich, and filled with the very molecules that sustain life on our planet. Here, in these lower reaches, our photon encounters a phenomenon that gives our world its most iconic and soothing color. It begins to interact with the countless molecules of nitrogen and oxygen that make up the vast majority of the air we breathe. This process is known as Rayleigh scattering, and it is a beautiful, silent dance between light and matter. Imagine the atmosphere as a vast, invisible ocean of tiny particles. As the white light from the sun enters this ocean, it isn't just a straight line anymore. While the longer, slower waves of light, the reds and the oranges, pass through relatively undisturbed, the smaller, shorter wavelengths of light, like the violets and the deep resonant blues, are far more sensitive. When these shorter waves strike a molecule of nitrogen or oxygen, they are caught and redirected. They bounce and scatter in every direction, leaping from one molecule to the next like a whisper passing through a crowd. This scattering is what paints the dome of the day. It is why when you look up from the grass on a clear afternoon, you don't see the cold, black void of space, but a soft, infinite canopy of blue. The light is being scattered so thoroughly that it seems to come from everywhere at once. It fills the sky from horizon to horizon, creating a ceiling of color that feels both immense and protective. It is a reminder of how the Earth's atmosphere takes the raw, piercing energy of the sun and softens it, turning it into something gentle that our eyes can rest upon. As our photon continues its downward path, the light becomes increasingly diffused. In the vacuum of space, shadows are harsh and absolute, either blindingly bright or pitch black. But here, within the embrace of the atmosphere, the scattering of light creates a pervasive ambient glow. The light curves around corners. It reaches into the nooks and crannies of the world, softening the edges of every tree and every stone. This diffusion is what allows the world to feel illuminated even when we are standing in the shade. It is a soft, wrapping warmth that ensures no corner of the surface is left entirely in the dark. Our photon is no longer a solitary traveler moving through a lonely vacuum. It has become an inseparable part of the daylight, that collective radiance that defines the rhythm of our lives. It is now part of the morning glow that filters through a bedroom window, the brightness that coaxes the flowers to open their petals, and the steady, reliable clarity that allows us to see the beauty of the landscape. There is a profound sense of belonging in this stage of the journey. The light has finally arrived at the place where it is meant to be, transitioning from a cosmic ray into the simple, comforting presence of a sunny day. We are drifting now into the final few miles of this 93 million mile odyssey. The air is becoming even more substantial, carrying the sense of the earth and the weight of the weather. We are entering the part of the sky where the clouds begin to form, where the atmosphere holds on to the moisture of the seas, and where the light begins to interact with the world in even more intricate and colorful ways. The journey is nearly at its end, and the world below is reaching up to meet us in a soft, breathable embrace. Now, we enter the troposphere, the very lowest layer of the sky, the cradle of all our weather and the air we breathe. It is a dense, bustling realm compared to the thin silence of the heights we've left behind. Here, the atmosphere is thickest, held close to the earth by the same gravity that keeps us grounded. It is in this layer that the air churns and moves, creating the winds that rustle the leaves and the clouds that drift lazily across the horizon. As our photon descends into this realm, the journey begins to feel more intimate, more connected to the world we know. As the photon continues its downward path, it encounters the soft white architecture of the clouds. These are not solid objects, but vast, floating collections of billions of microscopic water droplets and ice crystals. When our photon strikes one of these droplets, a beautiful and quiet transformation occurs. This is the process of refraction. Unlike the scattering we experienced higher up, refraction happens when light passes from the air into the denser medium of water. As it enters the droplet, the light slows down just a fraction, and its path is bent, as if it is being guided by a gentle hand. Inside the droplet, the white light of the sun is momentarily unraveled. It is split into its hidden components, revealing a spectrum of colors that usually travel together in secret. This is how rainbows are born. Each tiny droplet acts as a miniature prism, catching the light, reflecting it off the back of the sphere, and sending it back out into the world as a shimmering arc of red, fringe all yellow, green, blue, and violet. Even if there is no rainbow visible to the human eye, This silent dance of bending and splitting is happening all around us. Every time light meets moisture in the air, it is a reminder that even the simplest light contains a hidden world of color and complexity. The air here feels different now. It is heavy with humidity. This is the invisible vapor of the world's oceans, rivers, and forests. Rising up to meet the sky, it gives the atmosphere a soft, damp texture, much like the air of a quiet summer afternoon. Imagine the feeling of sitting on a porch as the sun begins to dip lower, the air thick and warm, carrying the scent of damp earth and growing grass. This humidity acts as a blanket, holding on to the heat of the day and preventing the world from cooling too quickly. It creates a sense of stillness, a weightiness that encourages the body to slow down and the mind to rest. The light moving through this humid air feels filtered and golden, as if it is being strained through a fine silk. We are now within the final few miles of this incredible 93 million mile journey. The long, lonely trek through the vacuum of space is a distant memory, replaced by the familiar, comforting textures of the Earth's lower atmosphere. Below us, the features of the landscape are becoming clear: the dark green of forests, the silver thread of a winding river, and the soft, rolling shapes of hills. The photon is no longer a cosmic traveler, it is a part of the local sky, descending through the last few layers of mist and haze. The journey that began 100,000 years ago in the crushing density of the sun's core is moments away from its conclusion. The world below is waiting, silent and still, ready to receive the warmth that has traveled so far to reach it. Take a slow, deep breath now. Let the air fill your lungs completely, holding it for just a moment before releasing it with a quiet, steady sigh. As you breathe, we are entering the final, most intimate stage of this long journey. The vastness of the solar system has shrunk down to the size of a single backyard, a quiet garden tucked away in a corner of the world. Here, the air is still and the sounds of the distant world are muffled, creating a sanctuary of peace. The scale of the universe has transitioned from the infinite to the familiar, from the cold vacuum of space to the warm, scented air of a summer afternoon. The garden is a tapestry of textures and colors, all of them waiting for the light. There are the soft, velvety petals of a rose, the rough, ancient bark of a cedar tree, and the smooth, cool surface of a stone bench. Everything in this space is poised in a state of quiet expectation. The plants have spent the day reaching upward, their leaves spread wide like open palms, catching the invisible energy that has traveled across the void. In this small green space, time seems to slow down. The frantic pace of the photon's birth in the core and its long, arduous struggle through the radiative zone are forgotten in the gentle, rhythmic rustle of a passing breeze. Notice the shadows that stretch across the grass. They are long and soft now, painting the ground in shades of deep emerald and cool indigo. These shadows are more than just the absence of light. They are places of rest. Within them, the temperature drops just a few degrees, offering a refreshing contrast to the sun-drenched patches nearby. A shadow is a sanctuary where the energy of the sun is momentarily held at bay, allowing the earth to remain cool and moist. Perhaps an insect is seeking shelter under a broad leaf, or a cat is curled up in the cool shade of a hydrangea bush, its chest rising and falling in a steady, rhythmic sleep. The shadows create a sense of depth and dimension, reminding us that for every beam of light, there is a place of quiet darkness where things can go still and recover. Our photon is now weaving through the branches of a tree, passing through the gaps in the canopy. It is no longer part of a blinding flood of energy. It is a single golden thread in a complex, shifting pattern of light and shade. It glides past a spider's web, momentarily turning the silk into a strand of liquid silver. It skims the surface of a bird bath, where the water is calm and clear, reflecting the infinite blue of the sky it just left behind. The journey is becoming very specific now, focused on a single moment of contact. The destination is finally fixed. Out of all the millions of square miles on the surface of the Earth, the photon's path is narrowing down to one tiny specific point. It might be the tip of a blade of grass, the center of a blooming flower, or perhaps the soft fabric of a shirt drying on a line. It could even be the skin of a hand resting on a windowsill, feeling the gentle warmth of the afternoon. There is no randomness left in this journey. The long, winding path that began 100,000 years ago is finally reaching its conclusion. The target is in sight, and the final few inches are all that remain. The journey of the light is about to become the story of the Earth, turning from a traveler of the stars into a spark of life on the ground. The final millimeter of the journey is crossed in a fraction of a second, so small it defies measurement. After 100,000 years of wandering through the dense, crushing interior of the sun and 8 minutes of racing through the cold, silent vacuum of space, the photon reaches its destination. There is no sound of impact, no flash of light to mark the moment. Instead, there is only a quiet, seamless transition. The traveler has arrived. Imagine this single unit of energy settling onto the surface of a broad, emerald green leaf. Perhaps a leaf on a sturdy oak tree or a delicate hosta in a shaded corner of a garden. The leaf is a masterpiece of biological engineering, its surface covered in tiny pores and coated in a thin protective wax. Beneath this surface lies a hidden world of activity where millions of tiny structures called chloroplasts are waiting. These are the engines of life, filled with the pigment we know as chlorophyll, the substance that gives the world its green hue. As the photon strikes the leaf, it is instantly absorbed. In the world of physics, absorption is a beautiful, intimate process. The photon's energy is not lost. It is simply handed over. It encounters a specific molecule within the leaf, and in that encounter, the photon ceases to exist as a moving particle of light. Its energy is transferred to an electron, giving that electron a tiny energetic boost. It is like a gentle hand pushing a swing, providing just enough momentum to start a new rhythm. This is the beginning of photosynthesis, the ancient and miraculous process that sustains almost all life on our planet. The energy that began in the heart of a star is now being used to break apart molecules of water and carbon dioxide, weaving them together into the sugars that the plant needs to grow. In this quiet garden, the light of the sun is being transformed into the substance of the earth. The photon's long journey has become a part of the tree's trunk, the sweetness of a ripening fruit, and the very oxygen that we pull into our lungs with every slow, deep breath. Alternatively, perhaps the photon does not find a leaf. Perhaps it finds a patch of bare earth, or the weathered wood of a garden fence, or even the soft skin of your own arm as you sit by a window. In these moments, the energy is absorbed and transformed into heat. You can feel this transformation as a faint, comforting warmth. It is a tiny vibration, a microscopic shiver of atoms as they receive the sun's gift. This warmth is the physical legacy of a journey that began before the dawn of human civilization. The energy that once fought its way through the sun's radiative zone is now a gentle hum of thermal energy, keeping the world at a temperature where life can flourish. Take a slow, deep breath and feel that warmth in your mind. The journey of the photon is over. It is no longer a lonely traveler in the dark. It has found its place in the grand cycle of the world. It has become the green of the grass, the warmth of the soil, and the energy in your own body. The vast cosmic distance between the center of the sun and the surface of the earth has been bridged, and the light has finally come home. There is no more need for movement, no more need for speed. The energy has found rest, and as it settles into the earth, it invites you to do the same. The long path is complete, and everything is exactly where it needs to be. The light is now a part of the stillness of the afternoon, a part of the quiet growth of the garden, and a part of the peaceful world that surrounds you. We have followed this single spark of light across a distance and a span of time that is almost impossible to grasp. It began as a whisper of energy in the crushing, silent dark of the sun's core, a place of unimaginable pressure and ancient stillness. For 100,000 years, it wandered, lost in a dance of collisions, bouncing through the dense plasma, waiting for its moment to break free. It saw the rise and fall of ice ages on Earth while it was still struggling to reach the sun's surface. And then, in a sudden, brilliant burst, it escaped into the void. It crossed 93 million miles of empty space in a mere 8 minutes, traveling at the ultimate speed of the universe, only to find its way to you. Think of that journey now. The energy that may be warming your skin or the air in your room right now is a traveler from another time. It is a bridge between the heart of a star and the quiet of your home. The same physics that powers the entire galaxy has ended its long trek in the most gentle way possible, as a soft glow, a bit of heat, or the green life of a leaf. The vastness of the cosmos is not something far away. It is right here, touching you, supporting the world you live in. There is a profound peace in knowing that we are part of this grand, steady cycle. The universe is vast, yes, but it is also intimate. As you lie here, let the weight of this story settle over you like a warm blanket. Just as the photon finally found its rest after 100 millennia of movement, you too can let go of the day's momentum. There is nowhere else you need to be, and nothing more you need to understand. The journey is complete, the light has arrived, and the world is bathed in its quiet, steady presence. Feel the rise and fall of your chest, a rhythm as dependable as the fusion in the heart of the sun. Your breath is a part of this living world, fueled by the very energy we have tracked across the solar system. Let your thoughts drift now, like a photon finally reaching the open sky. The darkness around you is not empty. It is a space for rest, a place where the energy of the day can slowly fade into the stillness of the night. The stars above are continuing their own long processes, forging new light that will one day reach another world. But for now, your part in the story is simply to exist in this moment of calm. You are safe, you are warm, and you are part of a universe that is beautiful in its order and its ancient, patient timing. Take one final slow breath. Inhale the stillness of the night and exhale any remaining tension. Allow the warmth of the sun's journey to remain with you as a lingering sense of comfort. The long walk is over. The silence of sex has been replaced by the soft sounds of the night. Close your eyes and feel the heaviness of your limbs sinking deeper into the soft support beneath you. The light has done its work, and now the darkness is here to guide you into sleep. Thank you for traveling through the heart of a star with me tonight. May your rest be as deep as the silence between the planets, and may your dreams be as bright and peaceful as the morning sun. Sleep now. Everything is quiet. Everything is still. Good night and sweet dreams.